From ContainerDays Hamburg, this video is proudly presented by DAX IT.
Thanks for joining the session today. As introduced, I'm Florian Trilov, system engineer at Veeam. Veeamkasten, there are so many different marketing namings on the way here, but yeah, we are talking about building resilience with effective backup and disaster recovery. For just an example, for vector databases on Kubernetes. Because talking about resilience in Kubernetes, talking about backup and restore, disaster recovery, some people are just saying, okay, I don't have something interesting in my cluster, I want to back up, but with also AI applications here, which are really tied to modern deployment ways, are running on Kubernetes today. And we will have a look today how we can do this and how we can back up also such environments with AI use cases. So starting, why should I consider using AI in enterprises? And why should I consider this using in Kubernetes environments? First of all, there may be different reasons for using AI here, but practically ways which is AI making a big impact in your enterprise applications. First of all, optimized resource management. Sometimes it is not predictable how your application will behave, especially also AI applications are sometimes used very heavily, sometimes not just this much. And it's a very big curve and very high and low altitudes on usage. So also performance and cost optimization is one very important topic. Intelligent automation here. We need automation to keep up with all the deployments, to keep up with all the ways how to deploy this and how the people are using it here. Security. It's all about detecting what's going on here. It's about detecting anomalies, blocking threats in real time to make applications much more resilient here. And this, we also heard today a lot about security and so stuff. This is built in Kubernetes, and there are so many add-ons now that you can run this also secure. It might be a really bad experience for a company or even the people are using it if your chatbot is going crazy because someone hacked it and it will give some very bad advice. We have seen this in the past, so even security for such modern applications is very important. And when it comes to user experience, AI enables personalization and natural interaction. So your user experience is not based on a hard framework, but based on how the users are using it. Another example is predictive maintenance. Predictive maintenance, we know this topic from also the aviation industry, where it is really popular and very, very important. Predictive maintenance is today also AI-based. It will get all the information and everything what's around this, and it's learning how to do this efficient, secure, and engaging. So why? Because this is for AI, but AI on Kubernetes is maybe a little bit special here because it is a real-life example how to use the full bandwidth of Kubernetes deployments here. Faster deployments, I think that's clear. I don't have to go into detail here. High availability, scalability. We heard also a lot today and also in the next days about high availability and scalability, how such an environment will scale. And this will solve one important topic I mentioned before, that it will be used in maybe a different way during the day and during the weeks. Portability, flexibility, and together with easy managing of distributed workloads here, your AI chatbot or whatever AI application, it's not a single application. It's running, completely distributed. We have even seen customers using a single application spread over different cloud environments, different Kubernetes clusters, different services here. So, and Kubernetes is built for that we can also do this cross environments here. Efficient backup and disaster recovery. Yes, this topic is special to Veeam, but it's really important. And I was really very positively surprised today that I heard, think about backups, think about disaster recovery, not just from the companies like Veeam, but also from other people here in the audience and also on the stage here, that this is a topic you have to think about in Kubernetes environments. And today, it's, I would say, solved. It's available. It's there because we have a large ecosystem and the community is growing so much, and we have a really big community. I think the ContainerDays are the second largest conference right after KubeCon. So we see that the people are here, the community grows, and that's very important topic. There was a report in 2024. The report asked, which of the following best explains the decision to use Kubernetes AI workloads in your organization? And you see here some points which we already talked about. Scalability, and also Kubernetes ecosystem. These are the top two ones here. So the people are asking for it, and it's there in the market. Another interesting chart from the same report, the same year, and we will see here the different years, blue 2021, black 2022, and now 2024 in, this is some kind of green. We see that databases are now the most common workload in Kubernetes environments. We were really surprised that because some people are just telling us, everything's stateless, we have nothing to protect here. Yeah, we have all databases outside. But especially for AI applications, this is not really true. Because a lot of people have their databases, like vector databases and RAG, running in Kubernetes together with their application here. And so, what about vector databases? Vector databases are essential for high-dimensional data storage. So it's not about a simple database with some key values or any relational databases here. This is an n-dimensional vector, and this is a set of n-dimensional numbers here stored there. So it's about the retrieval augmented generation. This is on RAG, and this provides a search engine and a recommendation system. So your information will get split here, so you can you don't have just this is an animal and a fork, or maybe a fork and green, but this is n-dimensional here, where you can store your data, and these are also high-performance databases, and they should be as close to the application itself here. So, to sum this up, vector databases store high-dimensional vectors, and these are representing unstructured data. You can have text there, you can have images, you can have audio. In earlier times, no one said, please put your images into a database. Everyone should or want to have this outside. Now this will come all into one database, and not just as earlier a key value store here, and also not just the document library where you have just some links and some data there, not just a graph, but this will all bring it together in a vector database. So this way, storing the data makes your search very, very efficient, because it now places, if you're looking at the graphic at the right side, where you have a bird, a sparrow, a cat, and a dog and a wolf, they're really close together because they are animals and they have some stuff in common. A banana would be put more than in the direction of an apple here. And you can also see Apple is really close to the logo of the Apple company. This is not directly there, but it is very close, and Google is also close to Apple here. So it will index your data in vectors here, and it is not just a simple search here. If we see this workflow, and this workflow is important when it comes to some outages and some recovery scenarios, you have your knowledge base here. So this is your doc retrieval, you have your embedding model here, and you have your vector database, and this is populated by, and the model is populating to the vector database here. And the user, your application, is just querying, the model is querying the data from the vector database. There can also be an LLM added to. I don't have this in the demo here because it's not needed for this use case, but it can also be extended here with an LLM. And so you will get the response here from this scenario. And now if we think about, what's happening when when my vector database isn't online anymore. And so now it comes to data protection. So data protection is very important here because it provides data integrity, security, disaster recovery, also version controlling here. You can roll back to an earlier version here. And for a lot of people, regulatory compliance is also a big topic here. And there are different ways how to achieve this. You can run just storage snapshots. We heard before in the talk before, storage snapshots is it's a good way to back up here. Storage snapshot with data services hooks, it's much more important. But having data service snapshots, using the native tools here of such a database to back this up, to have all the services here. And why not use all of this together? And this is what we will now do in the demo here. We will just back up and restore an application. A book nest application. This is a book recommendation chatbot here. It's question answers application with some semantic vectors. It's search in a vector database of books here. We have more than 300 dimension vector here, and the Bitnami PostgreSQL with pgvector extension is used here. This is quite common. We see this a lot, that pgvector with this extension is heavily used. So we will now start with a backup of this application. Therefore, we have the book nest namespace with all the components here, and we have custom.io with Kanister, and we will just back this up now. So my book nest application, it's running here. We have a chatbot here. We have some sample prompts here, like dramas about people and unhappy love. These are all informations which comes from this database here. We can also do a second one, a love story with happy endings. So we will see some other descriptions here, and we can just query it. This application is up and running now. So if you look at the Kubernetes system itself, we can look at the namespaces. We have everything in booknest drin, and we have also custom IO deployed here for all the backup stuff here in this environment. There are also some other workloads here, but it is just interesting that we have the booknest namespace here. If we go to the pods of the booknest, we can see that there's the chatbot deployment itself. There's the Postgres database running here. It's just a simple Postgres here. It's no HA system or stuff like this, and the notebook here. And yeah, if we exec into this database, just execing into the pod here, we are connecting to the database, and yeah, need some passwords. And in the next step, we will just have a look at the tables here. So we have our documents table here. Here everything is stored in. We have the sequence therefore. And so now we can see this application is up and running. This database is up and running. If we search inside this table, we will see the data here. We will see the ID, the author, the title, the description, and we will also see the vectors. This embedding here, and we will see now the text, and here all the vector information from the indexing. This is just the description, the description, and again the description as vectors. So if this gets lost, you might have a problem to get all the data. You might just search for a book, and you will get no answer here. So, and if there's a corruption in this data, your whole application might fail. If we go to the backup application here itself, we are talking about Veeam Kasten here at the moment, or Kasten IO, Kasten K10, however you want to name it. So this application, with this, we want just protect this database now. We can see our application. And we see here booknest, we see the default namespace here. This is the first entry point where we want to start to back up this application here. So we see we have some workloads here, we have some deployments, we have some stateful sets, and we have our data volume with this database. The one idea would be just snapshotting. Just creating a snapshot, and hoping that your database will come back up with all the components here. For sure, this is possible, but a database administrator would not really like it. So we want to do it the native way, how we can back up a Postgres database, and therefore we will use a Kanister blueprint. Kanister is an open source framework. It's a CNCF Sandbox project. And with this blueprint, this will be executed with Veeam Kasten doing a backup. And the important thing is that this blueprint can be fully customized. If it doesn't work in your environment, you can simply customize it here. So we have different actions. We have a backup action here in place, and this is just creating a kube task and creating a PG dump here. So we will just create a pod, we will start this pod and run a command. And this is just a PG dump of this database. We will get all the host and all the user passwords and so on. And we will push this now to the backup location. Therefore, we are using Candu as part of the framework here, and Candu will push the data to the backup repository here. This is fully open source. Kanister is fully open source and can also be used by other tools. So it is important to have a single way where to configure all these actions. And not just a backup, but also a restore action. Backup is simple, restore is the more interesting stuff here. And again, we are just doing a restore, we are just creating a new application with an empty database, and we will just import the data into this database back from the backup of all the Kubernetes application of our bookstore here. So we are using native tools. And a lot of people are asking, yeah, how is your database engine working? Our database engine can only work the same way and use the same tools like it is supported by the database vendors. No database vendor will accept a support ticket if you have used a non-certified or a non-certified tool and just provided some data in or pumped data into a system. You have to use these tools, but we will now operate these tools and use these tools during a backup and to restore. We will now just add this blueprint here. It's a Kubernetes object like everything in a good backup solution should be. For Kubernetes, we have a backup action, we have a restore action, and the delete action is for retiring restore points that we can also retire here. So we have a stateful set, and we will just annotate this blueprint to the stateful set here. We are just selecting it. You can also use a kubectl annotate. It doesn't matter. It can be done this way, or in custom it can also be done manually. But the most important information is just annotating the blueprint name, and Kanister together with custom will take care about this. We will write this to an Amazon S3 storage. You can also do it to another target like NFS, SMB, everything else. We're just talking S3 or public cloud. It doesn't matter. And yeah, we will now just create a backup policy, our test backup policy here for our for webinar. We're just doing this on a weekly basis here. Just setting some basic configuration, and it doesn't matter that all the parameters doesn't matter here in the end. We just want to run this backup once. So you can schedule this backup, you can use backup windows, however you want to set this here. The next one would be, we are just selecting our application here. We just want to back up our booknest application. This namespace should be backed up here. Here we will just add this namespace here. We will enable your backups, our backups also to our backup target. A snapshot isn't a backup. Everyone told you before, and Veeam is telling you this since years. We want to export this to our backup target, our S3 system here. Yeah, you can set retentions, whatever you like. And now we want just select here, our application. We want to export the database, and we have to tell them how to or where to export this database now. Therefore, we will just select this again as a location for our Kanister actions. As I said, Kanister is an open source framework. It can also be used outside of custom. It's good to have this with custom together because it's fully integrated there. But if you just have the use case to export the database, feel free to use also Kanister here as a standalone product. So now we just want to run this policy. We will just start this policy, yes, continue. And now these actions will be executed. As we can see, we have to get all the Kubernetes objects because just to restore, just having a database doesn't provide you capabilities to restore your application itself. So it will just getting all the specs here, all those Kubernetes components, and we are now running the commands we had into our blueprint. This blueprint will now be executed against this database. So in the background now, a pod will start, a Kanister job pod, and this pod will connect to the database, get all the, or just first of all, getting all the informations, we'll get all the data, now, we'll execute everything, and we can see it. Yeah, we have our Kanister action here. So it created the export to the database. There's nearly no data inside. So this is a really small application here, and we are writing all this to the backup target here. The result is we have a restore point, and then now if something happens, you are able, hopefully, to restore your application here. And something bad can happen all the time. It can be a faulty deployment. It can be just an insert into a database which will crash your database here. It can just also be a simple error doing deployment. For sure, you can redeploy. You can redeploy your application from an earlier stage, from your versioning control environment, for sure, but it will not bring back your database here. And someone can also just delete the namespace. So this is the easiest way how to destroy something in a very good way. So now my application is gone. My book nest application is down, and there are now different ways how to act. First of all, I can just redeploy my application. So, yep, it's done. So I can just redeploy it, but my data is missing here. In our case here, doing this demo, we will just restore the whole namespace. But you can also integrate this into your deployments. You can just do a redeployment of your application and run a data-only restore. For sure, this is possible. One important thing which might, and in this demo use case, I want to restore this with a transformation. I will change the ingress here because I want to provide this application, first of all, before the production restore to the department which is responsible for all the for this application to check if everything is right before providing the original ingress. And now we will just run a replace of the ingress path. It was /chat before, and we will now change this path here. And you can change this path also later on if everything is fine, everything is good. But we want to make sure that no one is accessing this application before the department just checked if everything is fine. So we will just say, okay, chat restore, and we will just use this transformation. Yeah, we have to change it here. We will just use this transformation here to restore. Thread minus restore, save changes. And again, a transformation is also a Kubernetes object. Everything is a Kubernetes object as it should be. Now we will restore this application here. So we will just select our restore point, our latest one we have just created here. The restore, okay, we want to restore it to the same namespace because that's fine. We just want to sorry, my bad. We are also using a new namespace, but it can also be the original one because we want just use the transformation now to change the ingress name so that no one else would use it here. Restore. So we will restore all components which are related to this application. As I said, you can also use your deployment infrastructure and just using a data-only restore here. Okay, going to restore, and now the restore of your application will start. And again, doing restore, the execution or the executor will now run the restore action provided in the Kanister blueprint. So an empty application will be restored, an empty database will be created here, and the restore action will now read the data and push the data into the database here. So this is one example on how to do this with a pgvector database here. The most important thing is that you have to think about to protect your application here and to protect your database. It can look completely different for another database. There will come up new databases, new versions and so on the market all the time. But this Kanister framework can be used for every database here. It can be used for any kind of application you want to protect here. And now you have everything together. You have everything what your application, our demo application was. You have everything together here now, and you have a backup of everything, and you can restore it. It's the way it was deployed. So to sum it up, please protect your data on Kubernetes. Especially your AI workloads are so important for so many people. So many people are just thinking about, what happens if my chatbot goes down and everyone is, or not just chatbot, all the other productive tools today which are running here. Please, this is your data. This is your reputation of your company, also inside and also outside. If you want to know more about how this can be achieved, please visit us at the Veeam Custom booth, right down the aisle. And very important, I talked about community earlier, join the Veeam and Kanister community. As I said, Kanister is open source. If you like this more, feel free to provide your insights also to Kanister, to provide some blueprints, to provide just a big community to build up, to have resilience in every application running on Kubernetes. And that's all. If you want to get started, there are just some links here, or just come to our booth. So that's all. Thanks a lot for today. And maybe there are some questions left.
The first one is about, what about distributed databases? Can Carsten help me with that case?
Mm-hmm. Yeah, distributed databases around multiple pods, multiple environments, for sure. In most cases, so export works all the time. So you can export the database and not just snapshot the volumes, but there are also operators which are providing a copy of the database somewhere in one environment, and it will just put this into backup mode or stop this replication here, for example, and then we can just snapshot and talk with the operator that doing a restore, this will be added to the original operator and used there. So it really depends on the database. Export is possible all the time, a little bit better with snapshots if we have direct integration too.
Thanks. And the next question is probably related. What are the performance implications on running a backup or restore?
Yeah, it's running inside your cluster. So it needs some CPU, it needs some memory here. These are just Kubernetes objects. So a data mover pod is also just using the resources they can use. So you can use limits here, you can set resource limits here. So from a performance standpoint, we take care about doing these operations that we don't overload this cluster. For sure, there's a mechanism inside, but have in mind that it will take resources, and please set limits whenever possible to not run into trouble.
Awesome. There are new questions coming in. Is there a way to do a point-in-time recovery?
Mm-hmm. So a backup itself is it's a point backup. So just creating a backup at exactly the stage it is scheduled. So if you schedule it hourly, you will get an hourly restore point. You can recover there. There are sometimes implementations for log shipping mechanisms and so on. This can also be done by Kanister, but it's a little bit more complex than just triggering a backup.
How do you handle inconsistencies within the file system? For example, during the database dump, linked files attachments might have changed.
So the database itself, it is, as I said, with Kanister, we are putting it in backup mode or just exporting it. If you might have like a WordPress application where you have also your WordPress, maybe volumes with some data there, we are triggering the export of the database and the snapshot at the same time. It's not 100% because CSI drivers have latencies and all the other components may have latency here, but it is triggered all together here.
Perfect. Last one for today. Can your solution work with Azure DevOps? Is there any plugin or extension?
So as Veeam and also Kanister is fully based on Kubernetes APIs, there's no need for a plugin or extension, as it can only create a Kubernetes object, create a restore action, and it will be executed by the Kanister controller or by the custom controller. So there's no need for an API, for a special API or special plugin or stuff like this, as this is just plain Kubernetes.
Perfect. Thanks again, and we will see each other soon. Thank you.
Thanks a lot.
From ContainerDays Hamburg, this video is proudly presented by DAX IT.